Now this is the first video for chapter 5, evaluating predictive performance. Now we're going to be looking at two different cases, one where the target variable is a continuous interval variable, okay, like the Toyota uh, cars example with price as the target variable y. Okay. The second case would be where the target variable is a nominal variable or a binary variable or a class variable. So either um, the observation is class is 0 or class equal to 1. Okay. So in these two cases, the kind of measures that we will look at that would evaluate performance is going to be different. In the case of predictive accuracy, so that is if the target variable is an interval variable, a continuous variable, then these are the measures that are important in a classical sense. Okay, so mean absolute error, mean error, and root mean square error, and so on. So where error is the actual value y minus predicted value for that y, which is y hat, and then you do all these computations with the error. Okay. And for the same predictive accuracy, there are a couple of other measures that we will look at, which are called lift. Okay. Here, we are not really interested in predicting one particular y value for a given set of predictor values. Okay, what is the predicted y value? If that was the case, then these are the way measures that will be important. But on the other hand, if you're really not interested in one particular value, but given a set of prospects, you want to compute. So, for example, you have say 1,000 Toyota cars, extending the Toyota car example. So you have 1,000 cars that are available for auction, right? Now, from those 1,000 cars, you want to narrow down the cars where you have the maximum. For example, let's assume that the most valuable cars, and out of that 1,000, you want to narrow down 100. So in which case you're really interested in ranking these observations. So where in such a case lift is a more appropriate measure, and we talked about lift in a different video. So how do we compute lift? So these are the two things we're going to do for uh, predictive performance. In other words, when your target variable is an interval variable. So we're going to look at how to compute these measures, and we're going to look at how to come up with a lift chart. Okay, so there are two kinds of lift chart that we're going to look at. So first thing first, we'll set up the default path to the folder that has all the data file. Okay, we set that, and then let's open some library packages that we will be using. So we'll be using these three, and maybe I don't know, maybe one or two more, and we will get. I think we will be using Caret. So let's put Caret also. Library Caret. Okay. So let's go ahead and run these four libraries. Okay. Next, let's load the data file. So we're going to be using the Toyota Corolla data file that we already used, I think, before. Maybe not. Toyota Corolla df. Okay, data frame equal to read.csv Toyota Corolla Toyota Corolla CSV. Okay, so we have the data file now. So there are 39 variables. Price is the target. Okay, so and let's set let's partition the data into train and valid. So well, before that, so when you bring in the data, let's do a head Toyota Corolla DF, and then we'll do a STR Toyota Corolla, and then maybe summary Toyota Corolla. Okay, so just to study, browse the data and make sure that everything is coming okay. So that we have the model, which is a character variable, and then the rest of them are integer. Okay, so here is top the first 6 observations, and then we have let's see whether there are any missing values anywhere. So it looks like there are no missing values anywhere. Okay, so now we're going to partition the data into train and validate. Okay, so let's first find how many rows there are in the data set. So that will be n row Toyota, right? And then we want to split, say, 60-40, 60% train and 40% valid. So let's say train.ind for index. Okay, so we're going to sample, and we want to sample numbers from the sequence n n dot row, right? N dot rows. Okay, see, when you do sequence n dot rows, so you'll get okay, I haven't run this n dot rows yet. Okay, so now you see that's SCQ code, and a number here generates a series of numbers from 1 through whatever the value of n rows is. So from that we will sample what, 60%. So 0.6 times n dot rows. Okay, so that will at random select out of that 1436, 60% of that, so that many numbers in that. Okay, in that sequence. So now we can do train.df equal to Toyota. Okay, and we want to select train.ind, those row numbers and all the columns, right? Then valid.df is going to be the remaining Toyota. Okay, so now square bracket, we say train minus train dot ind, come up. Okay, so now we run these two. Okay, we've already run train.ind. So when you run these two, so you get the two partitions.